All right, let's get right into it. We all live in a world that's just full of maybes, what-ifs, and pure chance. But what if I told you there's a way to actually make sense of all that uncertainty? Well, there is. It's called probability, and we're about to unlock how it really works.
I mean, think about it. We ask ourselves questions like this all the time. At its core, probability is just the language of chance. It's how we can put a number on all those nagging questions, from the small stuff to the really big life decisions.
And the best part? The basic idea is incredibly simple. We just measure how likely something is on a scale from 0 to 1. If something has a probability of 0, it's never ever going to happen. It's impossible. If it's 1, it's a done deal, absolutely certain. Every single other possibility, every maybe in the universe, falls somewhere in between.
Okay, so before we can start calculating any of these chances, we need to get on the same page. We've got to speak the same language. Probability has a few key terms that are kind of like our building blocks. Let's lock them in.
First up, experiment. Now, don't think of lab coats and bubbling beakers. In probability, an experiment is just any action where you don't know the exact result ahead of time. Flipping a coin? That's an experiment. Rolling a die? Also an experiment. It's simply the thing that you do. So, if the experiment is the action, an outcome is just one of the specific results you could get. You roll a die, landing on a 4 is one outcome, landing on a 1 is another outcome. You flip a coin, heads is an outcome. It's just a single possible result. Easy enough, right?
And if we make a list of every single possible outcome from an experiment, that complete list is what we call the sample space. It's the whole shebang, the master list of everything that could possibly happen. For a coin flip, the sample space is just heads, tails. For a die roll, it's 1, 2, 3, 4, 5, 6.
Now, here's where it gets really interesting. Look at how fast that sample space can blow up. If we roll just one die, we've got 6 outcomes. No big deal. But if we roll 2 dice at the same time, boom! Suddenly there are 36 different combinations you could get. This table lays them all out. And that's why knowing your sample space is always the first, most critical step.
All right, we've got the lingo down. So now for the main event. How do we actually calculate a probability? Well, it turns out there's one golden rule that gets us most of the way there.
And here it is. It's really just a simple fraction. The probability of something happening is just the number of ways you can get what you want divided by the total number of things that could possibly happen. That's it. It's what you're hoping for over everything that's on the table.
Let's make this super clear with an example. What are the odds of rolling an even number on a normal die? Okay, step 1. What's the sample space? All the possible outcomes. That's 1, 2, 3, 4, 5, and 6. So 6 total outcomes. Step 2. What are our desired outcomes? We want an even number, so that's 2, 4, or 6. That's 3 desired outcomes. Step 3, just use the formula. 3 divided by 6 is 0.5, a 50% chance. See? Simple as that. Okay, so that's how you handle a single event. But let's be real, life is usually more complicated than one roll of the dice. We often need to figure out the odds of multiple things happening. Like, what's the chance of this or that happening? Or this and that? Let's take a look. So to do that, we first have to understand 2 super important relationships between events. First up, you've got mutually exclusive events. Bottom line, these 2 things cannot happen at the same time. You can't roll a die and get a 5 and a 6 on that single roll. It's one or the other. Then you have independent events. This is where one event just doesn't care what the other one does. Flipping a coin and getting heads has 0 effect on what number you get when you then roll a die. Getting this difference is absolutely key.
Now, whenever you see the word "or" between 2 mutually exclusive events, that's good news for you. It means you have more ways to win. To find the probability of rolling a 5 or a 6, you just add their individual probabilities together. It's called the addition law, and it always widens your chances of success. But when you see the word "and," things just got harder. For events A and event B to both happen, you have to succeed twice. For independent events, we find this combined probability by multiplying their chances together. That's the multiplication law, and because we're multiplying fractions, it always narrows your chances and gives you a smaller final probability.
Okay, let's look at a classic problem to see this in action. Imagine a box with 14 balls inside. 6 are black, 8 are yellow. We're going to draw one ball and then a second one. What's the probability that we get a black one first and then a yellow one? Well, the answer depends entirely on one tiny detail. And that detail is whether we replace the first ball or not. This is so important. Look at the left side. with replacement. We draw a black ball, we note it, and then we put it back in the box. The game resets. For the second draw, there are still 14 balls. The events are independent. But look at the right, without replacement. Here, we draw a black ball, and we keep it. Now the whole situation has changed. There are only 13 balls left for the second draw. The second event depends on the first. And as you can see, that totally changes the final probability. This single concept is the logic behind everything from card counting in Vegas to how your insurance premiums are calculated.
So this is all cool theory, but what's the real-world payoff? How can we actually use this to make smart decisions? Well, that brings us to our final big idea, expected value.
Okay, expected value might sound a little intimidating, but it's really not. All it is a weighted average. It tells you the outcome you should expect to see on average if you could run an experiment over and over and over again. You just take every single possible outcome, multiply it by its probability of happening, and then add all those numbers up.
Let's use a lottery to see just how powerful this is. Let's say 10,000 tickets are sold. Here you can see the different prizes, how many of each there are, and the exact probability of winning each one. But I want you to look at that last row. The most likely outcome, by a long shot, with a nearly 98% chance, is winning nothing.
So what is one of those lottery tickets actually worth? When we do the math, when we calculate the expected value, multiplying each prize by its probability and adding it all up, the answer is just 2 naira. That's it. That means over the long haul, each ticket sold is only worth an average of 2 naira. Expected value lets us cut right through the hype and see the cold, hard mathematical truth of a situation.
So in the end, look, probability is not a crystal ball. It can't tell you exactly what's going to happen, but it's the next best thing. It gives you the tools to understand risk, to put a number on uncertainty, and to make much, much smarter decisions in a world that's full of chance. It helps you bet on the future more wisely. So the only real question left is, how are you going to use it?